So let's take a quick look at the differences between insertion sort written in TypeScript versus insertion sort written in C++. Right off the bat, they'll be very similar. So this is what insertion sort looks like in TypeScript. And same case, we're going to be looping through an array. And we are going to be swapping elements based on a conditional, and then returning the resulting array. So as you can see here, same case, taking in an array. We also take in size because how we access arrays in C++ is a little different. We'll be taking the key, so same case, taking an element at a given position and starting to work our way backwards. And as you can see, the conditions is very similar too. So while j is greater than 0, and while the index is j is greater than key, we're going to start the swap process. So as you can see, it's like the same situation, same condition. And one way that we can actually reduce the amount of swaps is that we don't do the last part of the swap until the end. So here we're swapping each, in the TypeScript solution, we're swapping each individual element. In this case, we're just moving the elements to the left one. And then at the very end is when we are going to do that last part of the swap and put the original element, the key element in its proper place. And so when thinking about this algorithm as compared to selection sort, we can say pretty definitively that insertion sort usually works better, because in its best case, this will insertion sort will make n-1 comparisons, whereas in the best case of selection sort, we're making n times n-1 divided by 2 comparisons. In the worst case, they both perform similar. So insertion sort and selection sort both have a worst case comparison of n times n-1 divided by 2. So insertion sort performs better when the input's likely to be already partially sorted. And as you can see, we're able to make a improvement on reducing the number of actual swaps. So not necessarily comparisons, but we are actually able to reduce the amount of swaps by doing the last part of the swaps at the end, outside of the while loop, rather than doing a complete swap on every single element. And so all you have to do there is just right outside of the while loop, just return. You swap the last element at the very end.